Folks, this is a short video clip that is going to be an explanation of how I failed in class and show you the blending process between the two rectangular cross sections. Uh, I, in case you want to replicate these steps, I put down some very specific dimensions here, and I'm not going to go back and forth between this one and the Catia interface. However, there's a couple of comments that I would like to make, and one of them is that uh, remember, if you change your dimensions so dramatically, some of these operations may fail. Okay, so there is no doubt about it. But at least for specific dimension that I've given here and things that are not out of whack, uh, this will work. And the reason that how I failed, how I failed back then, and I was unable to correct that right in class. I would like to attribute to two factors. One is that I could not see the screen. I could not see the projection on the wall, uh, and I could not lean forward enough to be able to see my screen on the desktop. Okay, so anyway, once I went home and looked at the problem, I realized that there was a way to fix that, and that's how I'm going to show you that. The other thing is that in the lab that night, somebody showed me that whatever I said, and I could not finish it myself, worked for him. But the way he drew these two rectangles were so that they were concentric. Let's put it this way: they had the same center. It was not offset like that, and yeah, that worked. But uh, now we're offsetting it and see how it works. Okay, so let me go to Katia. I'm going to start a part file. All right. And then I am going to, on this vertical plane, I will sketch a square that is 40 millimeters by 40 millimeters. Exit. And I will extrude it by 40 millimeters. That's the rectangle on the left side. Good. Now I'm going to create a plane offset from this vertical plane, which is 140 millimeters to the right of that. So let's go make a plane. Offset from this vertical plane, which is the XZ plane, 140 millimeters. There we are. And on it, I will draw that other rectangle. So on this, I will sketch. Okay, let me draw a rectangle like so, and we dimension it accordingly. So first of all, I believe that uh, the size of this is 10 by 20. So this is 20. Okay. Let's look at the normal view here. And the distance from, uh, let me move this thing because it's not constrained. Oops. Let me move this thing. The distance from here to here is 0.1. So let me actually move it there. So the distance from uh, I just noticed that because of the way I created this rectangle, okay, there is no center, but that means that I have to maybe it's easier if I actually went and did this thing as a centered rectangle. Yeah, let me delete this. You should be prepared for doing things like this on the fly. So there we are. Redrew this. Now it has a center. Let me put those dimensions. 20, 10. Okay, good. Remove this thing here. Now that dimension from this center to that line is 1 millimeter. Notice that the first time that I did it a few minutes ago, I did not have a center. I had to go and create a center, etc. So I had to bite the bullet and basically do it a different way. So dimension from this center to that line is 1 millimeter. That's in the drawing. Okay, and the distance from here to here is 10. The dimension from here to here is 10. Oh, this one, by the way, had to be 1 millimeters. So what you see is what I showed you a couple of minutes ago on the slide. There we are. And I'm going to extrude that. I'll extrude in this direction. It really doesn't matter. Yeah. So 40 millimeter, very good. Now, I would like to extract these 4 edges. So how do I do that? Here's the extract. If I select this, it's only going to do that one. But if I say point continuity, then it will do all of them. And I'll do the same thing on this side. So the second extract is going to be extracting this boundary. And because it was already selected point continuity, it takes the whole thing. Good. Excellent. So the next thing is you go to blend. First curve is that extract. It's easier if I did it from the tree. Extract 1. First support is that surface, that extruded surface. Second curve is that second extract. And the second support is there. Okay? Now, let me point out to you that there's a few things here that I could not read back then clearly on the screen. It says first point right there. First point right there. And the direction is clockwise. Second point is right there. And the direction is clockwise. Okay? So let's preview it. There we are. Now, let me cancel that for a second. And let me change, for example, some stuff. For example, change the second point to different position, because you don't have a control over, initially, you don't have a control over where the second point is. But so here's what I'm going to do. So look, let's try it again. Blend, first curve, extract 1, first support, that surface. Second curve, extract 2, second support is that surface. Okay? Now, it's the same thing that I did a minute ago. Notice that the first point here, direction is clockwise. Second point is here. These are the if you click on the closing point, see that? If you click on the closing point tab, it tells you exactly what they are. This is the second one, and it's at this location. Now, let me go ahead and change this. It just happened by sheer luck. Everything worked out fine. But let's say that I go and change this to a different location. For example, that location. How do I do that? I select it, I replace it with this. Okay? So the second point went from here to here. The direction is still the same, still clockwise. And I say preview. Look at what happens. There. So you don't have a control initially when you draw these things over where things are. And That's what happened to me in the class because my second point on the left side and the first point on the left side and the second point on the right part did not really make sense. It was probably something like that. So what I'm going to do, let me put it back and see whether it works. So let me, for example, go and take this and put it up there. Remember, I moved that to that up there. It didn't work. So I'm going to take this first point and move it up there. Let's see. So this is the first point. I'm going to replace it with that guy. And I bet that's going to work. There we are. The moral of the story is that very similar to the multi-section surfaces and solids, these closing points must make sense and they cannot be, randomly either selected or if they're generated randomly by the software, you have to go and fix it up. Okay? One last thing before I go, and that is notice that if I go back to the basic, there is two pull down menus here. Right default is tangency. What that means is that these blending surfaces that you create be tangent to the joining surface. Look, this is tangent. Whatever I created is tangent, either on this side or on these side. They're all tangent. And the same thing to the second support, which is right here, second. But if I take, for example, this first one, say point, and I update these red surfaces are not going to be tangent to the block on the left. You can see that. You see? The tangency is lost. Still, this is tangent still on this side. And I can even change that. You see? Anyway, so the reason that uh, blend and multi-section surfaces and things like that are I don't want to say hard, but they're more complicated than the other ones, such as extrude and shaft and stuff like that, or sweep. Even sweep is there are many options that you can select from. Anyway, that explains my failure in the class. My closing points probably were out of whack, and I could not see it on the screen properly to be able to change it. Good luck.